Lesson 95 is about integers, the concept of integers. We know a lot about integers already. We kind of use them naturally. The integers are all the whole numbers, like 0, and 1, and 2, and 3, and they just keep going in that pattern. But they also go to the left of 0, like -1, -2, and -3, and then they just keep going. So we can use integers when we talk about temperatures below 0, or maybe losing money, or being behind in a score. We're down by 5. That would be like -5. We also have to want to think about the definition of opposites. And opposites are integers that are the same distance from 0 on the number line. So if we go from 0 over 3, we arrive at +3. And if you go left 3, you arrive at -3. So +3 and -3 are called opposites. And another important characteristic of opposites is that they add up to 0. So 3 plus, and then we put this little negative sign here. And because we call this an operational symbol, and this is the sign of a number, we separate the operational symbol from the sign of the number with a pair of parentheses. That's important because if you have 3 minus -3, it can be a little confusing about what these signs mean. So likewise, we would put parentheses in here. So opposites are numbers that add up to 0. They're the same distance from 0 on the number line. Like 100 and -100 are opposites. 50 and -50 are opposites. The opposite of -25 is +25. So that's what integers are about. They occur naturally in the world, so we have to kind of know how to work with them. And this chapter will teach us how to add and subtract and multiply and divide positive and negative integers. The topic of lesson 96 is comparing and ordering integers, which means just use like greater than, less than, or equals to compare them, or if given several integers, put them in order from least to greatest or greatest to least. A general rule when you're comparing two integers, such as -3 and 4, if you compare them, you find them on a number line. There's -3 and +4. And the one that's farthest to the left is less than. So -3 being farther to the left than +4 is less than. So we use the less than symbol. Likewise, if we're putting some integers in order, like if we were given the list, let me scoot this up a little bit. Let's talk about, let's say, 7, 0, -3, 2, -4. We can find the one that's farthest to the left. In this case would be, 7 would be over here by 6. Sorry, it's not on the list, but we can imagine where it's at. 0, and 0 is a great reference point here, by the way, because everything that's positive, like 7 and 2, will come to the right of 0. So we could put 0 in. We can just start by listing 0. And we know 2 is less than 7. We're going from least to greatest here, by the way. And 7 is the highest, which leaves us with the -3 and the -4. And the one that's farthest to the left, when we compare them, which is -4, is the smallest. So -3 would be larger than -4. So if I want to work this way, I'll put -3 in here and then -4. So here's an example of comparing integers. And here is ordering integers. Lesson 97 is an introduction to addition of integers, and we're going to use a technique called counters to draw a model of each of these addition problems. Let's talk about when this might occur. When might you have problems like 3 plus -2 or -4 plus 5? And I'll give you different kinds of examples. 3 plus 2, -2 could be something like you have $3, but you owe $2. So what's your net? Like if you owe 3, if you have 3 and owe 2, after you pay, how much would you have left after you do that? Or maybe you're 4 points behind in a basketball game and you score the next 5 points. So are you ahead or behind? Positive would be ahead, negative would be behind. Or maybe the temperature is 7 degrees below 0, and then it drops another 2 degrees. So what's the temperature? Or 6 plus 1 is when you're used to. Maybe you have 6 pencils and you find one more. How many do you have altogether? So let's look at a technique that will help you always get the right answer. Although it's not useful for numbers that are really far away from 0, and you'll see why pretty quickly. This just helps you understand how it works. For positive 3, we're going to draw 3 positive signs, or 3 plus symbols. And that represents 3 positive signs. For negative 2, we're going to draw 2 negative symbols. This would represent a positive 1 and a negative 1, another positive 1 and another negative 1. So this is 2 positives and 2 negatives. And we learned in the first chapter that opposites add up to 0. So when we have 1 positive and 1 negative, 1 positive and 1 negative, when you put them together, you get 0. They're called 0 pairs. So we actually have 2 0 pairs here. So this is showing that 2 plus negative 2 is 0, but the whole picture is showing 3 plus negative 2 is a net of 1 positive. So 3 plus negative 2 equals 1. So I can't remember what the example was for this, but I think it was with money. If you have $3 and you owe $2, you're basically $1 ahead. So the negative 4 plus 5 could be drawn with 4 negatives and 5 positives, and you put them right above and below each other. Then mark off or circle or group an equal number of positives and negatives. And let me get rid of some of this stuff here. Yep, didn't want to get rid of it. So this was our problem. So the part that's the answer would be this 1 positive. So negative 4 plus 5 is positive 1. Negative 7 plus negative 2. It's a little different problem. We have 7 negatives, 1, 2, 3, 4, 5, 6, 7, and 2 more negatives. And we can't make any 0 pairs. There's no positives to pair up with any of the negatives. So the answer is just the total number of negatives that we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this answer is negative 9. And then the one that you're familiar with, you already know that 6 plus 1 is 7, but what would it look like with the counters? It would be 6 positives added to 1 more positive for a total of 1, 2, 3, 4, 5, 6, 7 positives. Lesson 98 is just going to introduce another strategy for adding integers, just to kind of build in us a way of thinking in terms of understanding what addition means. It's a putting together model. If we can use a number line, and again, we're limited when we do number line addition to just doing numbers that are close to 0. We're not going to use it to do 143 plus negative 285, and you'll soon see why. So we basically what we do when we use a number line is start at the first number that we're adding. So in this problem, we'll start at 8. Here we'll start at negative 3. Here we'll start at negative 5. And we're going to count our way to the answer. And so once we locate the first add-end, and it's all addition, there's everything's. In lesson 99, we're going to learn how to subtract integers. And just to make some common sense of this, if we were doing the problem 5 minus 3, one you're kind of familiar with, we could say, how far apart are 3 and 5 on the number line? So here's our 3, here's our 5, and how far apart are they in the distance? If we start at 3 and count over to 5, we see that the answer is 2. So it makes sense that this problem could be thought of as start at negative 3 and count over to 4, and it'll tell you, if you move to the right, that it's a positive answer, and it'll tell you the number of units that separate the two as we count. So we're going to count them from negative 3 up to positive 4. So we go 1, 2, 3, 4, 5, 6, 7. So this answer would be 7. Think about how we can make sense of that. Another thing that we did in the last chapter when we had a problem like 1/3 divided by 1/4 was the keep, change idea, and we made this 1/3 times 4 over 1, or 4/3, or 1 1/3. We can use the keep, change idea with subtraction as well when we want to. We would never use it for 4 minus 3, because you know that's 2. But this problem is not so obvious. So if we do keep, change, it could become 4, keep 4, change subtraction to addition, and take the opposite of the subtrahend, or the negative 3, and the opposite of negative 3 is positive 3. So 4 minus negative 3 is the same as 4 plus 3, which is 7. So just another example, if we were doing, let's say, negative 6 minus 8, we would keep negative 6, change addition, subtraction to addition, and make it negative 8. So we've applied the keep, change. And when we add two negatives, we would be, you could think about this, but hopefully we've moved past it. You would have 6 negative counters and 8 more negative counters for a total of 14 negative counters. So this answer would be negative 14. The topic of lesson 100 is multiplication of integers. Even before we start, I want to tell you that the rule for multiplying and dividing is the same, but it's not the same as adding and subtracting. When you add integers that have the same sign, like when you add two negative numbers, such as negative 5 plus negative 4, you can just add 5 and 4, 9, and give it a negative sign, because two negatives always add up to be negative. Two positives always add up to be positive. When you add a positive and a negative, sometimes the answer is positive and sometimes it's negative. It depends on which one you have more of, the positives or the negatives. Multiplication and division have a different rule. It's actually simpler. But let's think about what multiplication is to develop that rule. And we want to think of multiplication as repeated addition. So if you have a problem like 4 times 3, which you know is 12, that's the same as 4 added 3 times. It's repeated addition. So that's 12. So if you have negative 4 times 3, that would be the same as negative 4 plus negative 4 plus negative 4, which would be negative 12. Now if you have negative 4, let me make that a 4, times negative 3, it's hard to think of a model to actually explain what this would look like. But if you look at the pattern that we have, that when you multiply two positives, you get a positive. When you multiply a negative times a positive, you get a negative. It stands to reason, you notice the signs just switched. This was positive, this was negative. If you just change the sign of one of the numbers that you're working with, like we keep the negative 4 the same, and go from 3 to negative 3, there's no way that the answer can be negative 12, because the answer to negative 4 times positive 3 is negative 12, and this is a different problem. But it has to have something to do with 12, so the only logical answer is negative 12, which leads to the rule, by the way, that when you multiply numbers and the signs are both positive, like this example, the answer is positive. If the signs are both negative, then the answer, this should be positive 12, by the way. I'm not sure what the world I put a negative there for. And if you have a positive answer, you don't need to put the positive sign. It's just write 12. So when you have two negatives, the answer is negative, positive. When you're multiplying and the signs are different, the answer is negative. So this would be negative 12. So try this problem, 5 times negative 3. Think about it for a second. It's 15. Something to do with 15. Is it positive or negative? The rule is if the signs are different, the answer is negative. So this would be negative 15. If it was negative 5 times positive 3, it would still be negative 15. If it was 5 times 3, it's positive 15. And if it's negative 5 times negative 3, it's positive 15. To sum up the rule, when you're multiplying two numbers together, if the signs are both positive or both negative, the answer is positive. If the signs are different, then the answer is negative. The rule for dividing integers is the same as multiplying. When you divide integers, like when you multiply them, if the signs are the same, that is, they're both positive or both negative, the quotient's positive. If the signs are different, the answer is negative, or the quotient. Quotient means answer to a division problem. So just a couple of examples. If you have 8 divided by negative 2, That would be negative 4, which, by the way, you can show this problem as 8 over negative 2. It still means divided by. You have negative 16 divided by negative 4. The equation is positive 4. And look at the relationship between division and multiplication too, by the way. If you take the dividend, or the divisor, and multiply it by the quotient, you get the dividend. Negative 4 times positive 4 is negative 16. Negative 2 times negative 4 is positive 8. So in summary, that's it. It's a really short idea. You need lots of practice at it. But the rule is same as multiplication, same sign. Positive answer, different sign, negative answer.